and welcome to my new Geometry Notes tutorial. Today I want to show you some basic shapes and how you can do them, create them with Geometry Notes. I'm gonna start with how you can make this circle here, and you can change here the resolution and you can change the radius. And of course, I know there is a circle in curve primitives as circle, and of course I know also there are geometry mesh primitives which has a circle with the same inputs, but I just want to show you how to do this, and maybe this is interesting for you. And of course, what else I want to show you is making a star. Here you can change the points, and you can change the inner radius and the outer radius. Press on Geometry Notes, New, and I'm gonna turn on my screencast keys so you can see what I'm typing. So first of all, we want to make a circle. So by this we start with a mesh primitive, which is a mesh line. This line has 10 points, and it goes from 0 to 10, as you can see here. And we want it to go from 0 to 2 pi on the x-axis, so we change here from to endpoints, and on x we insert tau, which is 2 points pi, as you can see here, z to 0, and now we have here a line with 10 points from 0 to 2 pi. Why to 2 pi? Because if you have a circle has, if you paint here an angle in it, has an angle, and this angle for the whole circle is 360 degrees, which is in radians 2 pi. Because Blender always works with radians, I need here 2 pi. So if we have this circle here and we want to paint this x value here is cosinus from the angle, and the y value is sinus from the angle. So if you have a vector which has its cosine and sine as x and y value, we have exactly this point on the circle. And wherever you here make this triangle, you can always create these points on the circle. This is what we are doing here with the mesh line. This, don't think here of x, but think here of the x value as an angle. So if we now change the position of all these points here to cosine and sine, we should get a circle. So let's get white started and let's do this. So we use a set position here, and we take the position it has, and we separate x, y, z, where x is now our angle here. And from this angle we want to have the cosine, and this cosine, as I told you, is our x value. So if we plug this in here to our x value, and the sine is the y value, so we plug the x value, which is our angle, into the sine and plug this in the y value, and this result goes into the position. And as you can see, I'm gonna now delete my painting here. As you can see, we already have a circle. Maybe you wonder why we have now count of 10, but we have just 9 points. As you can see here, there are 10 points, 10 vertices, and just 9 points. This is because 0 and 2 pi is exactly the same point, so we have 2 points here. If you just want to have 1 point, that's no problem, we have a solution for this. You can just use merge by distance, which merges all vertices which are in a certain distance. Because this point here is now exactly on the same point, it will be merged or deleted. So here we have still 10, but if you look here, we have 9 vertices. This is, to be honest, yeah, 10 vertices, and here we have 9 vertices. If you hover over the end, if you select a node and hover over the output or input, you can get some information here. If you want a better circle, no problem, you just crank up the count and you get it. So now we want this a little bit adaptable. So we make this count as an input value, and because it's one value less, we just use a math node here and we add 1. So if you now plug use 3 here, we get a triangle, 4 and so forth. And if you crank this up, you get a really nice circle. So now how do we change the radius? Well, we just have to multiply. So we use a math multiply node with this value, and then you get what we want. So we double the group input here, and we put the multiply value in here, and we call this in the input radius. Let's check this out. This is now 0, 5 he says, and you see 1 and so on. Now we can change radius. This is already our circle group node. So we save this, and we are already ready with circle. Now we're gonna do and make a star. So we make a new geometry nodes here. So here is a new one, and now we reuse our node we already created because we can. And we go here to group circle, and if we now plug this in here, we got a circle. How do you make a star from a circle? Well, it's not that difficult. You just every second vertex we have to move to the center or outside the center. Then we got a star. So let's do this. How can we do this? Luckily, geometry nodes give us the index information, which is a number for each vertex, and it's counted from 0 to the number of vertices you have -1. So we use this index, and we use again the set position, which changes the position of the vertex. And now we use a mathematical function which is called modulo. Modulo is essentially just the rest of a division. So if you divide a value by 2, and it's an integer value, and index is always an integer, and it's this value here, you can see here, 0 to 7, you will get 0, 1, 0, 1, 0, 1. Because 0 divided by 2 is 0, 1 divided by 2 is 0, and the rest is 1, so I get 1, and 2 divided by 2 is 1, rest is 0, and so on. So you got by modulo by 2, you get 0, 1, 0, 1, 0, 1, so we get for this 0, 1, 0, 1. So if we just use this as selection, we move every second vertex, as you can see here. This is what we want, but we don't want to offset this on the x or y value. We want to offset this in direction to the center. How can we do this? For this we use the normal information, and normal is the value in which the outside, if you want so, shows. So the normal of this vertex points in this direction. This points in this direction. So if we plug this here in the offset, you see we already have a star. But one problem, so if I change now the count, you see the star looks a little bit bad. But on 10 it looks great again. And on 11 it looks not so great, and 12 it looks great again. I think you already know what this means. This means we need an even number of points so that the star is looking good. So to make an even number of points, we just make an input here, and we call this points. Or you can call it whatever you want. And now we use a mathematical function to make a number to an even number. It's pretty simple, just multiply it by 2 and then you got an even number. And now whatever number I have here, I will always have a perfect star. So this is the one thing we want to do. And of course we want to have the radius of the star. The radius is, as you can see here, this is now both. We just want to change one value. So what we need is another radius value. So we just plug this here again. And now we need a little bit of calculation, because this is our radius of the inner circle, and we can change the height of the points by using vector math. And there is a pretty handy function which is called scale, and by this you can scale the height, or if you want so, the outer radius. So now we call this inner radius and we call this outer radius. And of course this works by itself for the inner radius, because this is just the circle and this works, but we have to adapt the outer radius. And how do we do this? We just use a subtract node and we subtract the outer radius from the inner radius, and we put this in the scale. And if you can see now, here we can change the inner radius, here we can change the outer radius as we like, and here we can change the points.